is one of my favorite sections of chapter 3. You know why? Because it takes a little bit of work, and I like working hard. So let's get the intro behind it before we get to work. First things first, distance between a point and a line. So if I have a line and I'm saying what's the distance from some point to that line, we want to find the shortest distance possible. So for example here, I have this line AB and I graphed a point at C here. What would be the shortest distance? Well, I would say the line that is perpendicular to AB would be the shortest distance. So from a point to a line, the shortest distance would be the perpendicular line from that point that goes through that line. And we're going to find that distance here shortly. So first things first, perpendicular postulate. If given a line and a point not on the line, then there exists exactly one line through the point that is perpendicular to the given line. So this is kind of like our parallel postulate the other day. So if I have a line, a point that's not on the line, there's only one line that exists that goes through P that is perpendicular to M. And it's pretty good. Not totally to scale, but pretty good. So there's only one line that exists through P. That's my perpendicular postulate. Nothing too much there. All right, here's where we got to get to work. Well, let's talk through this first to figure out what we need to do. So line M contains points at 0, 0, and -5, 5. I graph this for the visual. Find the distance between line M and point B, which is at 1, 5. So we just talked about this. To find the distance between the point and the line, we want the shortest distance possible. So we want that perpendicular distance. So I'm just going to take a guess here at where this might be at. Something like that to find the perpendicular distance. So basically, I want to find the distance between M and point B. Well, here's V. Here would be the line. I want to find the distance of that line. The distance of that line. So let's think about some things we might need to know. I'm probably going to need to know the equation of that line. So I'm probably going to have to find the equation of the line. And we'll probably use what? Y equals mx plus b for that? Well, next thing I'll need to know, once I find the equations, I need to know the point where they intersect at. Well, if I think back to algebra, how do I find the point of intersection when I know the equations of the two lines? Well, that's where we set up a system of equations, because that will solve for the point of intersection. And finally, once I know the point where they intersect, and I already know V, now I have 2 points, so I can find the distance between those by applying the distance formula. So this is a process, isn't it? I got to find equations of the line, set up a system of equations, and finally use the distance formula. Ooh, boy. All right, well, we better get to work here. So first things first, let's find the equation for the line M. Well, y equals mx plus b. Do I know the slope of the y-intercept? Well, in this case, the y-intercept is 0, right? It goes through the origin. And then the slope, I can just count this, can't I? From one point to the other. So the rise would be down 1, 2, 3, 4, 5. So -5, right 1, 2, 3, 4, 5. -5 over 5, which is really -1. So my equation for line M would be y equals -1x, or I could just say -x, plus 0, because the y-intercept is at 0, isn't it? So there was my slope of -1, and y-intercept is 0. Well, now let's find the equation of the line through V. Well, I know it's perpendicular to this guy. It's perpendicular to the blue line. So I'm going to call this line P for perpendicular. So we're going to same thing, y equals mx plus b. And I know that it has a slope of 1 because it's the opposite reciprocal. of the blue line. So the slope of this guy is going to be 1 because here's -1. The opposite is a positive. And flip it. 1 over 1 becomes 1 over 1 still. So the slope of 1. So I know my equation is y equals 1 times x plus b. I don't need to write the 1. Well, what's my y-intercept? I can't just look at my graph and guess where my line's at. I need to actually solve. Well, I know a point that's on the line. I know it goes through 1, 5, don't I? So I can plug in 1, 5. 1 for x and 5 for y. And now we solve for b, -1, -1. So b is 4. So there's the equation for line P. I have y equals x plus 4, right? Because I use this equation and then I plugged in 4 for b. So now I have 2 equations. So I'm going to get rid of my work I just wrote here. With my 2 equations, I can set up a system of equations. So I have y equals -x, and I have y equals x plus 4. Well, we have a lot of ways to do this. We have substitution, elimination. If I look at this, I might just do elimination here. I don't know. Let's do substitution. Substitution might be easier. So if I see y equals -x, so that means I could plug in -x for y. So I'm going to do that. So I'm putting this in my second equation. And now I can solve this, couldn't I? I can add my x over, add my x over. So I got 0 on the left side there. 2x plus 4, subtract 4. And I'm left with -4 equals 2x. Divide by our 2, and x equals -2. And to solve for our y, we just got to plug this back into one of our equations. So I'm going to go ahead and I'm going to plug it back into this first one. So which is y equals well, I said x is -2, right? So y is a +2. The opposite of a -2 is a +2. So there's my point of intersection. -2 for x, 2 for y. So I'm going to graph that. So it's right here is my point of intersection. So I was pretty close on my estimate. So let me get rid of that line that I attempted to draw. So it's actually going through there. So now I have the point of intersection. I have the point of intersection, so I can find the distance between these 2 points. Isn't that what we're looking for, the distance between the point and the line? So how do we find the distance between 2 points? The distance formula. And to do that, I need to know my 2 points. Well, finding the distance between B, which is 1, 5, and the distance between the point of intersection, which I just found, -2, 2. And the distance formula, remember my shortcut, find the distance between the y's, which is 3. We square it. We add that to the distance between the x's, which is also 3, and we square it. So we get the square root of 9 plus 9, which equals the square root of 18. And I could leave it like that. Preferably, I would want to simplify it, or I could round it to the nearest tenth. It doesn't state it. I'm going to simplify it. So perfect square factors of 18 would be 9 times 2. So it's really the square root of 9, which is 3, times the square root of 2 units. So there is my distance. Or I could take it on a calculator and round to the nearest tenth. So that takes a little bit of work, doesn't it? I define both equations, y equals -x and y equals x plus 4. Right, the equation, the line it gave me, and the line that's perpendicular. Then I had to find the point of intersection by a system of equations. And then I found the actual distance by the distance formula. Okay, and I can follow the same process given 2 lines. Well, the distance between 2 lines, the shortest distance would be a line perpendicular. Well, before I could pick any part where it makes it perpendicular, but I need to know an exact point on a line to start with. So it doesn't matter which line you want to pick. I'm just going to pick this first one, y equals 2x plus 3. I know that the y-intercept is at 3. So I know this point right here. I know this point of 0, 3. So I want to find the distance from that line to the other one, where it makes a perpendicular right there. So I need to find where they intersect at, my system of equations. Well, if I look at this, I need the equation of the perpendicular line, and I'm going to need the equation of the line it intersects with. So I don't even need to worry about the other line, do I? When I'm trying to find the distance here. So all I got to do, if I pick 3 for my y-intercept point of that, I already have this equation of my blue line that I drew in there. Y equals 2x minus 1. And to find the equation of the line that's perpendicular, it's the opposite reciprocal of this slope. So the perpendicular slope would be the opposite reciprocal. So I'm taking 2 over 1 and I'm going to flip it to 1 over 2. And then we change the sign to a negative. So it's really negative 1/2 x. And to find the y-intercept, well, do I know the y-intercept? I do, don't I? Isn't it this guy right here? Y-intercept of 3? So that helps me out. That's why it's nice to have that picture, because I can visualize that with my green line, my line that's perpendicular. So now I have my two equations, y equals 2x minus 1 and y equals negative 1/2 x plus 3. And I'm probably going to do the same thing. I'm going to do substitution. I'm going to plug 2x minus 1 in for y here. So I got 2x minus 1 equals negative 1/2 x plus 3. And then we solve for x. So I'm going to add a half x over, add half of an x. So really I got 2.5x. I'm just going to add my 1 right away too. Plus 1 plus 1. 2.5x equals 4. And then we divide by 2.5. Divide by 2.5. And x is going to give us 1.6. And then to solve for y, we have to go ahead and plug it back into one of our equations. So I'm going to go in and plug that guy back in. I'm going to go up to my first equation here. So I got y equals 2 times 1.6 minus 1. Well, if I double 1.6, I'm at 3.2, and I subtract 1, or 2.2. So there's my point of intersection, 1.6 and 2.2. I'm going to write that right there, 1.6 and 2.2. So now we got to find the distance between the 2 points. That's 0, 3, and the one I just found, so we can find the distance between the lines. So I take the square root. This time I'm actually going to write this out. So remember, I subtract my y's. So 3 minus 2.2 squared plus subtract my x's. 1.6 minus 0 squared. Doesn't matter which order I subtract because they all end up positive when I square them. So really I got 0.8 squared plus 1.6 squared, which gives me, which is the square root of 3.1. And if I rounded that, let's round that guy. It's about 1.76 units. So that one I didn't have a nice, neat number to write in simplified radical form, so let's just round that. So 1.76 units. So it takes a little bit of work, doesn't it? And it helps to have a picture so I can figure out which point am I using, what equation of the line am I using, how am I going to set up this system of equations. All right, not too many problems, but they take some work, don't they? So think through it, use that picture to help you. Remember that process. Get the equations, set up the system, and then use your distance formula.